welcome to Feasible Physics. I'm Mr. Daubert, and today we're going to start a new series of videos that I like to call What I Wish My Students Knew Before Taking Physics. We're going to dive into a lot of different topics here, but the first one for this video is going to be all about algebra. Alright, so we're going to talk about algebra today. Now, I've broken this video into 3 parts to keep it simple for us. The first is just what do I expect in my physics class when it comes to algebra, so that we can kind of just bring down our stress level. The second thing that I want to talk about are just some basic tips and tricks about algebra that you can use to help you get better at algebra today, moving forward with your physics stuff. And the third part is just some sample problems. I've broken it into mild, medium, and spicy questions that we can look at and we can go through today so that you can feel just a tiny bit more confident with your algebra before you start your physics class. Let's dive into this first part about what to expect. Part 1, what to expect in terms of algebra in your physics class. I'm talking mostly in terms of academic physics, but this can also be applied to any sort of AP physics class as well. The first thing that I want to say as a disclaimer to kind of bring that stress down like we talked about was physics uses algebra to help us solve problems, but it's not quite as difficult as, let's say, a typical algebra class that you would take. We don't go into the depths of knowledge that a normal algebra class would expect you to. Physics is going to take just the basic skills from algebra and it's going to apply it to help us solve problems. I wrote out this example on the board to kind of illustrate what I'm talking about. First of all, I wrote out this equation here. It's y equals mx plus b. This is the equation of a line. In physics, you will almost always be given the equation that you need to use. Now, sometimes you are given a list of equations and you have to pick the right one that you need for that specific problem, and that's a whole different thing, and we'll talk about that later. I'm giving you this equation now. This is the equation that we want. We need to plug in numbers into our equation, which again is another algebra skill. Now, all of these numbers are not going to be listed out for us as easy as this is. They're going to be given in some sort of word problem, okay? Now, your word problem is going to be giving you a narrative. It's got to have a situation, and in that situation, it's going to tell you what these numbers are and where they need to go in terms of what variable they match to. In terms of algebra skills, we need to be able to plug in our numbers into the equation in order to solve for the missing variable, which was x. At this point, all that we need to do is move the 3 and the 2 over in order to solve for this x, and then we've solved the physics problem. This is as complicated as the algebra gets, so if this feels very easy, if you're like, oh yeah, I could do that, then you're on solid ground and you just need to relax and breathe. It'll be okay, we'll get through it together. The next thing I want to talk about are just some basic skills in order to get this x by itself. So that's going to get us into part 2 of this video, and that's just some basic algebra skills. Alright, we're into part 2. We're going to look at some basic algebra skills that you can take away today that will help you be better in algebra in your physics class tomorrow. The one big thing that I want to discuss with y'all is inverse operators. I know this sounds like fancy math talk, but it's really simple when you break it down to just the basics. I wrote out these 3 example problems here in order to kind of illustrate what an inverse operator is, and just as a review of how you do algebra. In all 3 of these problems, we are going to be solving for the variable y. That's why I underlined it in red. In all 3 of these variables, we've got different things happening to the y. We've got a 3 being added to the y, a 3 being multiplied to the y, and this y is now being squared. Now the question algebraically that we want to ask ourselves is this: how do I get y by itself? Because I want to know what the answer is for y. How do I figure out what y is? Let's start with this first one. If I want to solve for y, but there's a 3 being added to this, I want to ask myself, what is the opposite of adding 3? What is the inverse operator of an addition sign? If the addition sign is the operator, what undoes a plus sign? What undoes addition? And the answer is subtraction. If I'm adding 3, in order to get rid of adding 3, let's take away 3. So the opposite of addition is subtraction. So let's subtract 3 to one side. Now remember, there's that one rule from algebra that says if I do something to one side of the equation, I need to do it to the other. So we're going to subtract 3 from both sides. And that's going to get us something that looks like this. And now look, my y is by itself. My 3 has moved over to the other side using an inverse operator. The inverse operator for addition is going to be subtraction. And it also goes in reverse. So if this was a x equals y minus 3, let's add 3 to both sides to undo the subtraction. So this is the easy one. This is the one that we hopefully just know because we've done a lot of algebra already. Now the next one that I want to look at is this multiply by 3. We're going to ask ourselves again, I want to move this 3 over to the other side, so I have to undo multiplication. So I ask myself, what's the opposite of multiplying? What is the inverse operator of a multiplication symbol? And that is a division symbol. If I'm multiplying something 3 times, if I divide something 3 times, that's going to undo what the multiplication is trying to do. So we're going to divide both sides by 3, and that's going to cancel this 3 out. And you can do this too, where you cross things out if that helps you stay organized. So if I can come back over here and cross out the 3 and the plus 3, so that reminds me, oh, I got nothing over here with this y. So the 3 being divided canceled out this multiplication, and so we're left with x divided by 3 is equal to y. So that must mean that my inverse operator for multiplication is going to be division. But remember, these inverses work both ways. If we start with a y divided by 3, you can multiply to get rid of the division on one side and to solve for your y. Now let's get to probably the most complex thing that you're going to have to do algebraically, and that's dealing with this square. If I'm trying to solve for y, having a square on the y is a problem because it's not actually by itself. There's 2 y's here, and we need to deal with that. So we have to ask ourselves now, what is the inverse of a square? What is the opposite of squaring something? This one probably isn't as intuitively easy to think of just off the top of your head without memorizing it, but the inverse of a square is a square root. Now a square root looks like this. So I'll draw it here. There's that big square root. This is a button on your calculator. Hopefully you've seen this before. A square root is the same thing as y to the 1/2 power, which would cancel out this 2. So we square root both sides because algebra, what we do to one side, we have to do to both sides. This square root cancels with this square. I know that looks a little funny, but it's okay. And that's going to leave us with an answer that looks like this. The square root of x is equal to y. And now y is all by itself, which is perfect. That's exactly what we want. So the inverse, and I'll have to use an x down here just to keep it simple. The inverse of a square is going to be a square root. And remember, this works in both ways. So if I start with the square root on this side instead of a square, you can square both sides to get your answer y and basically undo what you need to do. Now here's the good news, and this is where I want you to kind of like decompress any sort of stress that you have built up at this point. These are the 3 main inverse operators that you need to know to be successful for the entire school year of physics. Isn't that nice? We don't have to worry about cubes, we don't have to worry about any sort of other weird operator that's going to show up in our equations because the equations don't get any more complicated than these 3 inverse operators. So if you can do this, then the reorganization part of your algebra is done and you are good to go. We're going to move on to part 3, and that's some example problems that I'll go through with you guys using these inverse operators. So stay tuned, we're going to get to that in a second. We are into our first practice problem for today, and this one is going to be mild. This is an easier problem. It's going to have less steps for us algebraically, and hopefully this is a good intro into doing algebra with physics. Now here's the cool thing. I'm going to give you only physics equations that you'll see in your future class to practice with today. No other random equations. These are actual physics equations. So this is force equals mass times acceleration. This is F equals ma, Newton's second law. We'll get to this more in future videos. If you would like to practice solving for A on your own, pause the video here and check back with me here in a hot second to see if you did it right. I am going to go through my steps in order to solve this problem for A. A is my answer, and I need to move M to the other side in order to solve for A. Now I can see here that M and A are being multiplied to each other. I know it doesn't look that way because there's no multiplication sign drawn, but we know that in algebra, if the 2 letters, the 2 variables are next to each other with no plus, minus, division sign, anything like that, then we can assume that there's a tiny little multiplication mark between the 2. So think back to our inverse operators from the last part. What is the opposite of multiplication? And the answer is division. Let's divide M to both sides. We can cancel, and that's going to leave us with F divided by m is equal to a, or we can write it as a fraction, f over m is equal to a. And this is our answer. If you pause your video and you work this one out on your own, check your work, see what you did. This is a mild question. It should have felt pretty easy, pretty fast. Let's get on to a more complicated question. We're gonna get into a medium one here in a second. All right, team, we are into practice problem number 2. This one is a medium question. I chose this one as your medium question because it has a few more steps algebraically, and there's some weirdness going on in here with this little f and this little I, so we're gonna talk about that first. Now, if you would like to pause this video and solve this problem on your own, you're solving for t, you can pause the video here and come back and check your work here in a second. Now, the first thing that I want to say is VF and VI. Notice that they both are V's. They both stand for velocity that tells us how fast we're going. The problem is they both are the same letter, but we want to keep them separate from each other in our variables because they represent two different ideas, our starting velocity and our ending velocity. Now, in physics, we do this by putting tiny letters next to the big letters. They're called subscripts. The only thing you need to worry about with subscripts is they need to stay with the big letter. You don't actually have to move any letters out of them. You're not going to divide anything here. You're not going to do anything to move the I and the F away from the V. They stay with the V. So don't stress out when you see the little letters with the big letters. They're just helping us stay organized. Now, in this problem, we're solving for t. We want to know what's our time in this problem, meaning that the problem already probably told us the final velocity, the initial velocity, the acceleration, and we're solving for time. In order for us to solve for t, we need to be doing some inverse operator. Now, I have a VI that needs to move over, and I have an A that needs to move over. Now, the question is, which one do I do first? Am I going to subtract the VI because it's being added, or do I divide the A because it's being multiplied? There's a good rule of thumb that you can follow whenever you're doing these problems, and that's following the inverse order of operations. Now, what that means is think back all the way to your middle school math. Order of operations tells us to start with certain math operators first, like parentheses and exponents and multiplication. So we know what order to do the math. Now, for algebra, when you're moving letters over from one side to the other, we're going to follow the opposite order of operation. At the back end of the order of operations is your addition and subtraction. So we're always going to try to start with addition and subtraction first. This is step 1, because that's the last thing that we normally do in the order of operations. So that means we're going to move VI first because that's going to be a subtraction, which is what we're going to do for step 1. Let's subtract VI to the other side, and that's going to leave us with VF minus VI is equal to A times T. At this point, we still want to solve for t. That's still what we're looking for. But we need to move this a to the other side. And we can see, again, there's a little hidden multiplication sign here, and we need to undo multiplication with division. Thinking back to order of operations, normally multiplication and division come before the addition and subtraction, but since we're following the opposite order of operation, this is going to be step 2 for us. So we're going to divide a to both sides. And that's going to cancel. I forgot to do that up here. Now, we're going to cancel the a's, and that means t is now by itself, which is really nice. In order to keep everything nice and pretty, I'm going to put some parentheses around the VF and the minus VI, so that I know that these need to happen first. And then I'm going to divide everything by a in order to keep everything nice and pretty. And so, my final answer looks like this. Now, if you paused your video to try this problem out on your own, check and see if you got this far. Maybe some mistakes could have been you divided A first, and that maybe messed up some other things. If I divide A here, then A has to go with the VI and all of this other nonsense where it gets really complicated and really messy. Maybe you did the wrong inverse operator, or maybe you wrote this final answer part down here incorrectly where A was only dividing VI or VF. But remember, A has to divide both of them, and that's why I put them in parentheses here. So you can see why this is more of a medium problem, because we had to do 2 steps to get to the end. And we had to decide, am I going to subtract first or am I going to divide first? And we talked about that inverse order of operations to help you decide which one's first and which one's second. Now here's the good news. Once you do enough of these problems, and you probably already have, this order of moving what first becomes very innate, and you actually are going to just know off the top of your head which one is naturally going to move first from one side to the other. This ends our medium problem, and we're going to get into the last practice problem for today and the last part of this video, and that's going to be our spicy problem. we have our last problem, and it's a spicy one. I chose this problem because it has a square root in it. It's got a few more steps in order to get to the final answer, and it's just a little bit more complicated than everything else that we've looked at so far. If you're interested in pausing the video and solving for m on your own and then coming back to check your answer, definitely do that. So if I want to solve this problem for m, I know and I can see there's a lot of things around m that are going to need to move to the other side, and that's where I might get a little overwhelmed and I might get a little stuck. In order to figure out what to do first, think back to the order of operations and do it backwards. In the order of operation, typically we would do the square root first, and then we do the multiplication second. But we're going to do the opposite. We're doing the division first. So step one is going to be to divide things, reverse order of operation. So we're going to divide the 2 pi over to the other side. Now, 2 and pi are just numbers, right? Pi is just 3.14, so they can actually get moved together, which is nice, or you can plug them into your calculator and you can just get a number that's like just 6.28 and move it to the other side. You can do that too. It doesn't really matter. We're going to divide 2 pi first. That's our first step, okay? So that cancels, and we've moved the 2 pi over to the other side. Now I'm going to write this as a fraction because I feel like the fractions help me stay a little bit more organized. Step 1 is done. Step 2 is we need to deal with the thing that's affecting m and k, and that's the square root. So it would be a mistake for us to try to move k first because k is inside this square root, which means the square root is actually working on k right now. And that's a problem because before we can move k, it's got some baggage attached to it. Let's get rid of the square root second, and that's going to help us get to our next step. So we're going to square both sides. That's our step 2. So we're going to square this side here, and we're going to square this side here. That causes the square root to go away. So I'm going to rewrite my equation, and you can see how I'm using parentheses here in order to help me stay organized because there's a lot of things happening. We don't want to get lost because I forgot a parenthesis, and so the square only went to the t, but the square is acting on the t and it's acting on the 2 pi, so the parentheses are important. Now my last step is going to look like this. I've got m divided by k is equal to t over 2 pi squared, and I want to move the k to the other side. Now it's being divided, so that means the opposite operator for k being divided is going to be multiplying, okay? I almost messed up that k. It's all good. K is going to get canceled. We're going to rewrite this over here because I've run out of room, and we are going to have a final answer that looks like this. T over 2 pi squared times k is equal to m. All right? And that's your final answer. If you paused your video, check your work. How'd you do? Did you get to the end? Definitely double check your steps and see where you maybe have missed something, okay? This is more of a spicy question because we had to make some decisions about what happens first and what happens second. We also had to do some inverse operators like using square to undo a square root. We also had to do 3 full steps. I didn't write that down here, but look, here's your 3rd step. We had to multiply down here at the end. We had to do 3 steps of algebra to get to the end. Now here's my biggest bit of advice for you moving forward going into your physics class. Do you see how I listed out my steps in order to get to the end? Your teacher is going to want you to show this. I want my students to show this every single time they do their work because if I don't see any steps here, then 1, I can't help them, right? I don't know where the mistake was made because I can't see the thinking from step 1 to step 2 to step 3 to the end. The other thing that's going to happen is if you are purposeful with your steps, then these complicated problems become a little bit more simple because you're baby stepping to the end. And that's what we want to feel. We want to feel like we're confident and we know what we're doing through our tiny steps to get to the final answer. And you're not going to see this equation until like mid-year, maybe close to the end of the school year, but this is a real equation that you're going to have to deal with at some point. All right, we got through all of our algebra today. We talked about what to expect in your physics class in terms of algebra and why you shouldn't really be stressing too much about the math side of physics too much. We talked about the basics of algebra that you're going to need to know and apply to physics so that you can be successful with these math problems, talking about inverse operators and things like that. And then we looked at those 3 practice problems, the mild, the medium, the spicy. Now, if you couldn't get through all 3 of them, that's okay. There's still more practice coming ahead, so look out for that. And just a quick reminder, you got this. It's all good. Okay, I know physics can be a little scary, and I know that some people have probably told you, oh, I can't believe you're taking a physics class. It's going to be so bad. You're going to hate it. No, it'll be fine. you'll do great. And we'll get through it together. As a reminder, I'm Mr. Daubert. This is Feasible Physics. We've got more videos coming at you with just some more things to know going into your new physics class next year. Thanks for spending some time with me, and we'll see you again soon.